Welcome to another lesson. In this lesson we are going to solve some limit questions. As previously we explained about limit. We do some exercises about limit, then we're going to explain calculating and finding limit, then we do some more exercises. Let's begin with this question. Question 8. Use the graph of f to find values of c where the limit x tends to c f x exists. Values means the answer is more than one value. Let's look at this graph. In this graph, the limit exists. The limit exists everywhere. It has no problem, except this. This number is -3. Then at x equal to -3, the limit does not exist. This means everywhere else on the graph of f, limit exists, then the value of c could be any real number except -3. Then this is why in the question it says values, not only one value, because c could be so many values. Even this 2, the limit at 2, limit exists because right side of 2, left side of 2, both approach 2. At 2 the limit exists and the result is 2. This means c could be 2, c could be any other real number except -3, because at -3 the graph is broken, it has no limit. Question 9, there is a piecewise function. We have this. The question says, sketch the graph of the function fx. Fx is this function. Then find the value of c where the limit x tends to c f x exists. Okay, if we look at this, the only place that limit does not exist is where x equal to 4. At x equal to 4, the graph is broken. It's 2 pieces. Then limit does not exist at 4. But everywhere else on the graph, limit exists and it has no problem. This means the limit exists at all real numbers except 4. Then c could be any value, but not 4. This question 10. Use a calculator to find limit x tends to 0, fx, where fx is 1 plus x power 1 over x. Look at this. What we have? 1 plus x all power 1 over x. This is the function we have. And by evaluating limit, okay, f of x at when limit approaches 0. Then since we want to use limit when x approaches 0, if I put 0 in place of x, I'll get something like this. 1 plus 0 power 1 over 0. Because of this 1 over 0, this is an indeterminate form. It's undefined. Then what we do, we don't go to 0 directly. We go to the left side of 0, right side of 0. And we have the graph of the function. We have the graph of this function, 1 plus x power 1 over x. The graph is like this. Then this is 0. If we approach 0 from the right side, the graph is approaching this point. If we approach 0 on the left side, on the graph, left side is approaching to the same point. So the limit at 0 exists. And the result, on the right side of 0, let's choose something too close to 0, 0.01. This number is on the right side of 0, and it's too close to 0. When I write this in place of x, using calculator, the result will be 2.7. And on the left side of 0, I'm going to choose another number that's too close to 0 and negative. I'm going to choose negative 0.01. This number is too close to 0. Then if I replace x by negative 0.01, I will get something like this calculation. By calculator, we get this, and it's equal to 2.73. This means on both sides of 0, the graph is approaching 2.7, 2.71. Then, since the right limit and left limit are both approaching the same number, then the limit at 0 exists and it's equal to 2.7. After this, we have some true-false questions. Then let's look at them. Question 11. The function f is not defined at x equal to c. If the value of f is something that is not defined at a certain value, then the limit does not exist. This is false because we have functions that it has problem at a certain value, but the limit exists. Here is the answer. Question 11 is false. For example, if we have this fx equal to x cubed minus 1 over x minus 1, this is also an example that we solved previously. If I want to find f of 1, f of 1 means replace each single x by 1. We will have something like this. F of 1 for this function is 1 power 3 minus 1 over 1 minus 1. This is 0 over 0. That's undefined. Then f of 1 is 0 over 0. It's undefined. But if I want to find limit x tends to 1 for the same function, I'm going to expand, factorize this, then this factor can cancel x minus 1. How can we factor something with power 3? X power 3 minus 1. To factor this, we consider the 1 as 1 power 3. 1 power 3 is also 1. It has no problem. Then look at this. We have two terms, minus between them, and they are both power 3. What do we do? Firstly, we write them without power 3, x minus 1. Then we write term 1 power 2, opposite sign, first times second, always plus 1. Then if we factor x cubed minus 1, we will get x minus 1, x squared plus x plus 1. That's what we have here. Then, as you see, we have x minus 1 down. We got another x minus 1 up. These two factors cancel out each other. We will end up having only a trinomial, x squared plus x plus 1. Then if I replace x by 1, I'll get like 1 plus 1 plus 1. That's 3. It will not be something over 0. So it's okay. The limit exists, but the function does not exist. Twelve says if the value of a function is a certain number, then the limit is the same. Then value of function and limit could be different. This makes 12 false. Look at this function. This fx is a piecewise function, and the question says if it's false, give an example. If we can have at least one example is not satisfying this, then we cannot say this is always true. Then this will be false. Look at this function. In this function, we have a piecewise function. The value of the function will be 1 if x is equal to 1. The value of the function is 2 if x is not 1. Before we had a note, if we want to find limit for such functions, then we don't go with the equal, we go with the not equal. If I want to find limit x tends to 1 for this function, I don't use the 1, I should use the 2, which is not equal. Then f of 1, it's obvious, f of 1 is 1. But limit x tends to 1 for fx is 2. Then the value of the function exists and it's equal to 1. The limit exists and it's equal to 2. This means they are not equal. Here it's written L, L. This means they are equal, the function and the limit, but we show that they could be different. This makes question 12 false. Question 13, it's like question 12, but in a different order. It says if the limit exists and it's equal to a value, a number, then the function is equal to the same number. Then, using the same example of question 12, we can show that that cannot be true because we have a function that has a value, while the limit of the same function has a different value. Then we can use the same example of question 12 for question 13. 14, fx is equal to square root x, all right. Is it true that limit x tends to 0.25 is equal to 0.5? Since this is not a fraction, if I directly substitute 0.25 in place of x, the result is 0.5. It's correct. Justify your answer. We have the graph to justify. This is the graph of square root x. When x is 0.25, the result is 0.5. Or we can say, since it's not fraction to form an undefined form, then we can directly substitute and we will get the result. Another thing is it true that limit x tends to 0, square root x is equal to 0? Of course, if we put 0 in place of x, square root x is 0. At 0, we don't need to do left and right, because left side of 0, which are the negative numbers, are not in the domain of this function. Then we don't consider some numbers that are not in the domain for limit. Then this limit at 0 exists and it has no problem. The result is 0. When x is 0, y is 0. When x is 0.25, y is 0.5. Then this makes question 14, A and B both correct, true. If we look at this diagram, this is the graph of square root x. When x is 0, y is 0 as well. When x is 0.25, y is 0.5, that's obvious. Question 19 is a good question. Let's look at it. The figure on the right shows a rectangle and an isosceles triangle. Here we see a rectangle and we see an isosceles triangle. Isosceles triangle means two sides are equal in length. Then inscribed in a circle. Inscribed means it's completely inside a circle. It doesn't have any corner outside the circle. Circle of diameter 1. The diameter of the circle is 1. Diameter of the circle is 1, means from here until here is 1. What is the value of x that will make the area of the rectangle and the triangle equal? Then x is the width of the rectangle, b is the base of the rectangle, which is also base of the triangle. Then let's do this. In the Kurdish book, it's written radius equal to 1. This is why this answer might be a little bit different from the Kurdish, but this answer for this question is correct. Now, we begin with writing the rule of area. Rule of area of rectangle is length times width. For this case, rule of area is b multiplied by x. X times b, b times x, doesn't matter. Area of triangle, for such questions, we just begin with what we have, then we think about what we do. Area of triangle is 1/2 times base times height. That's area of triangle in general. For this triangle, to find this height, if diameter is 1, means radius is 1/2. If diameter is 1, means radius from circumference to center is 1/2 or 0.5. This side is x. Half of it over 2x. Then if I want to find h, I say 1/2 minus x, what's remaining is h. For this question, h is 1/2 minus 1/2x. This is the value of h, as you see here. Then we want the area of rectangle to be equal to area of triangle. Then we write this area equal to this area, as we have here. xb is equal to 1/2 b times h. Instead of h, we have 1 over 2 minus x over 2. Simplifying this, if I divide everything by b, as b is common, divide everything by b, this will cancel, this will cancel. What's remaining on that side is only x. What's remaining on this side is 1 over 2 times 1 over 2, which is 1 over 4. 1 over 2 times x over 2 is x over 4. To remove this 4, I multiply everything by 4. Then these two will be cancelled, and this will be 4x. Now I have 4x equal to 1 minus x. Minus x goes to the other side, become plus x. So 5x equal to 1. Divide by 5. X equal to 1 over 5, which is 0.2. 0.2 is the value of x that makes the rectangle and the triangle equal. Okay, evaluating limits. To evaluate limits, we have some basic rules. Where we focus more is we don't always have to simplify or multiply by conjugate. We'll see all the cases. Firstly, if we have to find limit, we just replace each x by 2. For polynomials, polynomials means when there is no fraction, no radical, no root, no fractional powers. All right, then this is a polynomial. Since x tends to 2, we just replace each x with 2. Then we get the result, negative 61. So the value of this limit is negative 61. This way is also called direct substitution. Because the function does not form any indeterminate form, the answer will not be undefined, then we can directly substitute and get the result. Let's do this, check it out. Since this is polynomial, it's not fraction, it's not root, the powers are not fraction, then it's direct substitution. Directly replace each x by 2, then calculating the result, we will get the answer of the limit. If there is fraction, sometimes when we directly substitute, we will get 0 over 0, then we need to simplify. And most of the time, when you look at the fraction, we don't always need to factorize, simplify, cancel the terms. Test, directly substitute once. If you don't see 0 over 0, then it's your luck day. The answer is directly this result. Now for this one, if I directly put 2 in place of x, this will be 2 power 2 minus 1, that's 2, not 3. 2 power 2 minus 1 over 2 minus 3. 2 power 2 is 4, minus 1 is 3, 2 minus 3 is negative 1, so the final result is negative 3, not negative 1. The final result, 3 divided negative 1, is negative 3. That's obvious. Another one, x tends to 2. If I directly substitute, it will be 2 plus 2 over 2 minus 2. 2 plus 2 is 4, 2 minus 2 is 1. That's 4 over 1. This is 4. This is the answer. And it's correct because we don't have any undefined forms. Here, undeterminate form, this is where the result becomes 0 over 0. When the result becomes 0 over 0, there are 3 ways of getting rid of the 0 over 0 based on the function. When you see 0 over 0, we either factor and some factors cancel out, or we multiply by conjugate, or we simplify. Then let's do this. Limit x tends to 1, x squared minus 1 over x minus 1. If I directly replace each x with 1, I will have 1 squared minus 1, that's 0, over 1 minus 1, that's another 0. Then I got 0 over 0. This 0 over 0 means I need to simplify. I need to simplify this. Simplifying, since I have x squared minus 1. In the first lesson, I explained something called difference between two squares. I'm going to recall that quick. if you have two squared terms like 1 minus 1, x squared minus 1, this one basically we can say it's 1 power 2. This will be two brackets, one of them x minus 1, one of them x plus 1. What we have here is x squared minus 1. Then instead of x squared minus 1, I can write x minus 1, x plus 1. And in the denominator, I already have x minus 1. So x minus 1 cancels out x minus 1. What's remaining is just x plus 1. Now, if I do the same limit for the function which simplified to this, x plus 1, it will be limit tends to 1, x minus 1, x plus 1 will be 1 plus 1, that's 2. The result of this limit is 2. We have this checkout. Check this out. If I directly put 1 in place of x, it will be like 1 squared minus 3 times 1 plus 2 over 1 minus 1. 1 minus 1 is obvious, that's 0. This one, let's calculate. 3 times 1 is 3. 1 minus 3 is negative 2. Plus 2 is 0. Since I got 0 over 0, I need to simplify this to get rid of the 0 over 0. Now let's factor this. To factor the quadratic equation, so pay attention to this way. Factoring quadratic equation, I have x squared minus 3x plus 2. We need two numbers. When you multiply, we get 2. And when we add them, we get negative 3. For these numbers, since there is negative, the numbers should be negative. Negative 1 times negative 2. If I multiply these two negative numbers, the result will be positive 2. So it satisfied the first condition. I multiplied two numbers. I got positive 2. That's okay. Now, if I add these two numbers, negative 1 plus negative 2, the result will be negative 3. That's also correct. In the exam, for these positive negatives, use calculator and be safe. Then negative 1 plus negative 2 is negative 3. That's what I need. Then these two numbers are good numbers to write them in the brackets. So instead of this quadratic expression, I'm going to write x minus 1, x minus 2. Because the two numbers I have, one is minus 1, one is minus 2, so here they are. In the denominator, I have x minus 1. Then x minus 1 cancels out x minus 1. What's remaining is x minus 2. Then if I put 1 in place of x, 1 minus 2 is negative 1. The result of this limit is negative 1. This is another case. This is another case. If I directly put 3 in place of x, I will get 0 over 0. Let's see. If I put 3 in place of x, it will be square root 3 plus 6 minus 3, the square root stops here, over 3 minus 3. I only put 3 in place of this x and this x. Then I got this. 3 plus 6 is 9. Square root 9 is 3. 3 minus 3, that's 0. And this one is 3 minus 3. Then this is 0 over 0. What should I do? In the case of having square root, we need to multiply by conjugate. We cannot factor to cancel. We need to multiply by conjugate. Conjugate is what you see here. We write the same thing, and instead of this minus, we write plus. And if this is plus, we write minus for the conjugate. Then we will multiply up and down of the fraction by conjugate of this expression. The conjugate, as I said, since it's minus 3, square root x plus 6 minus 3, we don't change anything in the square root, only outside the square root, it's minus 3. We're going to write plus 3. Then since we multiply up by this conjugate, we need to multiply down by the same conjugate to keep the balance. Then how this becomes this, Pay attention to this step. I have this multiplication, square root x plus 6 minus 3 multiplied by square root x plus 6 plus 3. That's the function, that's the conjugate. Then the first number, which is a square root, this should be multiplied by both. If I multiply two terms that are the same, and they are both under square root, when I multiply them together, the square root will be cancelled. An example, if I multiply square root x by square root x, the result will be x. Okay? Same thing is true for x plus 6. If I multiply square root x plus 6 by square root x plus 6, the result will be only x plus 6. Okay. Square root x plus 6 times 3, it will be positive 3 square root x plus 6. Now the square root x plus 6 part, finished, multiplied by both, I got two terms. Negative 3. If I multiply negative 3 by this, I will get negative 3 square root x plus 6. And if I multiply negative 3 by negative 3, the answer will be negative 9. Negative 9. This is why we multiply by conjugate, because the middle terms will be like this. 3 radical x plus 6, negative 3 radical x plus 6. And these two together will be 0. What's remaining at the end is x plus 6 minus 9. This 3 will not be added with the 6. This 3 is gone. So everything about this term is gone. X plus 6 minus 9. Plus 6 minus 9 is negative 3. This is why we have x minus 3 up. That's what it's remaining. Another note is for the denominator, we don't multiply out. We don't multiply these together and expand, simplify. We don't do this. Never expand and simplify this when you are doing conjugates. Now, we have x minus 3, x minus 3. These terms cancel out each other. What's remaining is 1 over the conjugate, x plus 6 plus 3. Now, since the numerator is 1, it will not be 0 over 0. Then it's not an indeterminate form. If I replace x with 3, it will be square root 3 plus 6 plus 3 in the denominator, and 1 is in the numerator. This will be 9. Square root of 9 is 3. 3 plus 3 is 6. And 1 over 6 is the final answer after multiplying this by conjugate and cancelling the term that forms 0 over 0. This, check it out, has the same idea. Let's do this to master conjugate. Don't forget for every question, firstly, do the direct substitution, because it might not be 0 over 0. Then if it's not 0 over 0, direct substitution can get the job done. Let's do this. If I put 5 in place of x, this will be square root 5 minus 1 minus 2 over 5 minus 5. 5 minus 1 is 4. Square root of 4 is 2. 2 minus 2, 0. 5 minus 5 is 0. Now, since I see 0 over 0, then I need to simplify or factor or multiply by conjugate. When you look at the function, there is root. If there is square root, multiplying by conjugate is the best way. Then if I multiply this by conjugate, it will be like square root x minus 1 minus 2 over x minus 5. Now, I'm going to multiply this by square root x minus 1 plus 2, and down, same thing, square root x minus 1 plus 2. Close. Here, if I multiply these two together, I will get x minus 1. Let's write this here. I'll write the final answer here. They are the same thing under root. If I multiply, I'll get x minus 1. 2 times this, it will be negative 2 x minus 1. Then negative 2 times 2 is negative 4 at the end. And there is square root x minus 1 times 2 is positive 2 square root x minus 1. In any order we multiply, it doesn't matter. Now we see this minus 2 square root x minus 1 will be cancelled with 2x minus 1 under square root. What's remaining is x minus 1 minus 4. X minus 1 minus 4 means x minus 5. Down, as we said, we don't multiply these out by each other. We keep it as it is. And eventually we have an x minus 5 down with square root x minus 1 plus 2. These two cancel out. The result will be 1 over square root x minus 1 plus 2. Now, if we put 2 in place of x, if we put 5 in place of x, the limit tends to 5. If I put 5 here, 5 minus 1, 4. Square root of 4 is 2. 2 plus 2 is 4. Then the final answer is 1 over 4. Now let's see some more questions. In exercises 1, 2, 3, find the indicated limit. Let's see. This is polynomial, it's obvious. I'm not going to need any simplification, any conjugate, nothing. Direct substitution. Direct substitution, replace x with 1. 3 times 1 cubed minus 2 times 1 squared plus 4. This is 3. 3 times 1 is 3. 1 power 2 is 1 times 2 is minus 2 plus 4. Then the answer is 3 minus 2 is 1 plus 4, that's 5. Here, if I directly put 3, it will be 3 plus 2, that's 5. 2 over 5 is the answer. That's direct substitution, it will not be 0 over 0. And this one, again, if I directly put 3 in place of x, it will be 3 plus 1 under root over 3 minus 4. 3 plus 1 is 4 under root, that's 2. 3 minus 4 is negative 1. Then 2 over negative 1 is negative 2. The final answer is negative 2. Now let's solve some more questions. We have this exercise 4 and 5. We have some limits we need to find. Let's do them. Firstly, this is fx. This is gx. If we want to find part A limit x tends to 1 for fx, directly put 1 in place of x. 5 minus 1, the answer is 4. Limit x approaching 4 for g. Then put 4 here, 4 power 3, 81. 4 power 3 is 4 times 4, 16 times 4, 64. Anyways, direct substitution can get it done. This one is a little bit different, although it's not way too different. We need to put f in g. Put f in g, it will be 5 minus x all power 3. What is this? This is g of fx. G of fx is 5 minus x cubed. Then if we want to find x approaching to 1, replace this x by 1. It will be 5 minus 1, which is 4. 4 power 3. Then it will be the same as this. This question 5. fx is this, gx is this, then these are direct substitution. This one, put 4 in place of each x. Here, put 21 in place of x. 21 plus 6 is 27. Cubic root of 27 is 3. These are obvious. Here, we need to put f again in the function g. Let's see how it looks. If we put this f in function g, it will be 2x squared minus 3x plus 1. If we put this in g, it will be under cubic root plus 6. Okay? There are two ways. We can either do this for part C, or we can find f approaching 4, the result, put the result in g, we'll get the answer. This way is better. Now here, if we do this, this will be 7. Then x approaches 4, put 4 in place of each x. 4 squared is 16. 2 times 16, 32. Minus 3 times 4 is 12. Plus 7, all under cubic root. We can easily get the answer. It will be 20 plus 7, 27. Cubic root of 27 is 3. The final result is 3. That was the answer of part C. Here are some trigonometric questions. Then let's do them as well. Limit x tends to 1 for sine pi x over 2. If I directly substitute, well, if I don't see 0 over 0, then it's direct substitution. Let's look at this. Sine pi, x is 1. Pi times 1 is still pi over 2. Sine pi over 2 means sine 90 in calculator. Pi is 180 degrees. Then if you don't know what is pi over 2, in your calculator write 180 over 2. You see 90, then write sine 90, you will see 1. Cosine 3x. What is x? X is pi. Then this, if I directly put pi in place of x, it will not be 0 over 0. Then direct substitution is okay. If you answer this one here, it will be cosine 3 pi. Then cosine 3 pi, we can do it by calculator. 3 times 180, cosine of that number gets it right. This one, limit x approaching 3, pi over 4. Put 3 in place of pi, it will be 3 pi over 4. Consider pi as 180. 3 times 180 divided by 4, you will get an angle. Then tan of that angle will be directly the result of question 8. Similarly for question 9, if we put 6 in place of x, it will be cosine pi times 6 over 6. 6 cancels 6. Cosine pi means cosine of 180. Cosine of 180. Cosine 0 is 1. Cosine 90 is 0. Cosine 180 is negative 1. 1 over negative 1. The result will be negative 1. This is the end of this session. Thank you so much for watching. Stay tuned to see the rest of the book. Comment your questions so I can answer you. Thank you for watching. Bye.
گروپی لاس بۆ فۆتۆکۆپی و پەراوگا لە خزمەتی قوتابیانی خۆشەویستدایە بۆ ئەوەی لە وەرزی نوێی